Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. And today we have Harpreet. Harpreet, tell us a few words about yourself and about the tool you want to show us. For
Hey,
those
what's
who
up,
do not know
everybody?
you. Yeah.
Oh yeah, yeah. What's up, everybody? My name is Harpreet Sahota. I'm a developer relations manager here at Desi. My second time on the open source spotlight. I was here back a while ago with super gradients, just showing how to do image classification. But now we're showing how to use our new object detection model called YOLO-NAS. A little bit about me: I've worked at a few different MLOps type companies, Pachyderm, Comet, now at Desi. Previous roles was a lead data scientist and building data science teams, was an actuary and biostatistician before all that. And now I'm here. I'm doing the fun stuff.
Mhm. Doing open source Spotlight things. Okay,
Yes.
let's see the demo.
Awesome. All right. Well, here it is. We're going to jump right into this notebook here, YOLO-NAS. I'll share the links with Alexi. I'm sure he'll put it in the comments. There'll be a couple of different notebooks. There's one that's complete starter notebook, and here's a little bit more bare bones, but let's go ahead and get into it. You're about to witness the power of YOLO-NAS. So that's what we're going
I'm
to
excited.
yeah, that's what we're going to get into. We do have a technical blog here that you can check out that'll have all the details about the architecture and training. So I've linked to it here, pretty in depth. We're not going to be publishing a paper, at least not yet, but the technical blog has all the details. But in a nutshell, what is YOLO-NAS? Well, first of all, what does the NAS stand for? NAS. That stands for Neural Architecture Search. Um, we used neural architecture search to find this particular architecture. So what neural architecture does is it kind of automates architecting and engineering a neural network. And you need three things to make this happen. You need search space, a search strategy, and some way to evaluate the performance, the estimated performance of the end architecture. Our search space was inspired by YOLO v6, YOLO v8, and the QA rep VGG blocks that I've linked to in this paper here. So that's
What does
what.
YOLO stand for? You live
So
only
you,
once?
yeah, you live only once. Yes, that. Unless you're like me from the Sikh faith, then you live many lives. But YOLO just stands for you only look once. So that's the the meaning of that. Um, and so our architecture, like I mentioned, it's inspired by YOLO v6, v8, and the QA rep VGG blocks. QA means quantization aware. So what is quantization? It's just a optimization method for reducing the size of your neural network, but still at the same time maintaining performance. And what we're doing is we're substituting floating point numbers and the floating point numbers in the weights to lower precision values. So this helps reduce the memory size and computational costs of the neural network. So we've got a link here. I've linked you here to this ultimate guide on quantization. So go ahead, check that out. It'll have all the details you need to kind of understand that. YOLO-NAS also uses a hybrid quantization method. And what hybrid means here is it selectively quantizes only parts of a model. And again, we go into depth here about hybrid quantization in this blog, so you can learn all about that as well. Another interesting feature fact rather of YOLO-NAS is that it's pre-trained on a lot of data, MS Coco, Object 365, and the RoboFlow 100, and it's pre-trained using a semi-supervised learning approach. So we're using kind of pseudo-labeled data to help train the model. We go into detail into the technical blog as well, so be sure to read more into that. But because the way we trained it, this technically counts as a foundation model. So this is really a foundation model for object detection because it was trained on a wide variety of data using semi-supervised methods. So again, tons of detail if you're interested in that in the technical blog. Check it out, or just shoot me an email if you have questions. I'd be happy to get those answers for you. So here's the interesting part about YOLO NAS. So these are the results for the standard YOLO-NAS and the Intate quantized YOLO-NAS. And you're seeing here that we're actually performing better on Coco on the T4 GPU compared to the modern YOLO architectures. So it's a new state of the art, essentially.
For those who don't know what Coco is and what is it?
Yeah, Coco is a object detection data set. It's a standard benchmark that's used to evaluate the performance of new object detection architectures. It stands for Common Objects in Context, I believe. It's a data set put out by Microsoft, and it covers 80 classes. So anytime you get a model that you're kind of using off the shelf and you're doing inference with it and you haven't like fine-tuned it or done any transfer learning, those 80 classes that it's detecting is coming from Coco.
Mhm.
So that's what Coco
And
is.
object detection is like when you have a picture of, and then on this picture you have multiple objects. The task of the model is to find these objects on that picture, right?
Yeah, that's right. So image classification, you typically would just give an image and it'll kind of give you the classification of the image of whatever it is that's taking up the center of that image. Object detection is like, okay, well, we're doing classification and we're locating the objects in the image. So we're doing two tasks at once. And so that's what you only look once means, because typically you would, before the original YOLO in 2016, you would have had to do two passes to make that happen. But now we're just kind of doing it in one shot. And I wrote a newsletter post that I can also share here with Alexi that kind of talks about the evolution of YOLOs. There's been 15 YOLOs since 2016. Even though there's the YOLO V8, there's a bunch of, you would think that there's only 8 versions, but there's like 15 that have come out since then, and now we have the
Just
16th
like
one.
things like NAS do not have a number, right?
That's right. Yeah, that's right. So that's just a little bit about YOLO-NAS there. But we're here just to kind of see it in action. So we'll go ahead and do that. So YOLO-NAS lives in the supergradients library. Supergradients is a PyTorch-based library. So if you're familiar with PyTorch, if you're comfortable using PyTorch, you can still take YOLO-NAS from supergradients and use it in your, whatever PyTorch code that you have. Um, so it just makes working with PyTorch a lot easier, as you'll see in this notebook. So we'll go ahead and start by importing supergradients and importing RoboFlow. Supergradients will take a couple of minutes to install. So just be aware of that. And then once you install it, you're going to have to restart the notebook. This is a known issue that we're actively working on fixing. But once you get the installation set up, restart the runtime, and you'll be good to go. Here's just the standard imports, but we're going to first get a sneak peek of inference with the YOLO-NAS, how quickly it is to perform inference with the YOLO-NAS. So here is an image, and it's just a URL to an image. And we're going to use a small version of YOLO-NAS. YOLO-NAS comes in 3 versions, small, medium, and large. And we're just going to take this URL, pass it to the model, and get a prediction. And that's what's going to happen here. And again, we're using just a small version of this particular model. And we'll get some detections in just a moment here. And this is a rather large image that I've passed to it. We'll get that inference right here in a second. There we go. Scene from The Office. Here looks like a bat behind the stage. Scene from The Office, and you can see here that's able to pick up most detections relatively well. And again, this is just using the small model, and I've adjusted the confidence so it's just at 50%. You can toy around with that if you like. But that's how easy it is to start getting predictions with the YOLO-NAS. We also have a predict webcam function, which I could link you to, but it's also in the larger starter notebook that I linked to in this very notebook as well.
Mhm. What would be the use case for this camera stream? So, for example, if I, let's say, want to detect cats coming to, I don't know, the camera, then the moment there is a cat, it would trigger
Yeah,
something, right?
yeah. So a really good example that I've seen out in the wild is my friend Kristen Kerr. She did this object detection model where she detects when her children's school bus passes by the window of her house, because she knows that as soon as a bus passes by the window of the house, it goes down the street, makes a U-turn, comes back, and it takes a few minutes before she has to get her kids out there. So she set it up so that it detects the bus and then sends her a text message like, "Hey, the bus has just passed the house. Get your kids ready." So that's a good use case there. I've also seen it
That's cool.
for a number of other a variety of use cases, but I think that's a really fun, interesting one.
Yeah, nice.
And if you're interested, you can look into the actual architecture of the model. Like, it's a PyTorch model, so you can use Torch Info Summary to get that information. And you can see exactly what's happening in every layer of the model. Here, the small model we're working with has less than 20 million parameters. So that's the model there. Here we're using the RoboFlow. We're going to use a RoboFlow data set. So particularly this data set, which we'll kind of just do real quick exploration on. But it's 359 images, so very small data set. And as we'll see here, this function right here is just splitting the data set, because once you get it from RoboFlow, it looks something like this. You got all the images and all the labels in one folder. So I'm just kind of splitting it into train, test, and validation. So that's what's happening there. This is just a configuration file just to kind of store the variable names, just keep everything nice and tidy for us. So that's what's happening there. And now we'll kind of take a look at the data that we're working with. So this is just a quick class distribution of the data. You can see here that we've got underrepresentation for the dice that shows 5 on its face, lots of dice that show 6. This is just counting the number of detections that we have in each image. So here we've got detections that, so of the 369, whatever it was, detections that we had, this is the number of 2s that we have amongst all those. So that's just quick kind of way to understand how the representation of the distribution of images in each, sorry, the distribution of dice in each image. Sorry. Here is just not predicting, but it's just plotting real quick the raw images. So we can take a look at the type of images that we're training on. You can see here that the images aren't really the best. Like the dice are really small. The dots are really small. It's taken at a high up angle, so it's a very tough data set to work with. But we'll go ahead and experiment with it anyways. The first thing that we do here with super gradients, once we've done our exploration, set up the configuration file, it's getting the trainer set up. So this is one of the most important things about working with super gradients, right? The trainer is in charge of training, evaluation, saving checkpoints. And there's 2 important arguments that you need to pass to the trainer. That's the checkpoint root directory. So this is the directory where all of your experiments will be saved, and then the experiment name. So all the checkpoints, logs, tensor boards, etc., will be saved in a directory with the name that you specify here. So if we instantiate the trainer like so, it'll create the checkpoint directory here for us. Our experiment is called rolling the dice, and it'll have all this information there for us. So this is a really important part to instantiate. So super gradients also offers something called data parallel and distributed data parallel right out of the box. That's out of the scope for this discussion, mostly because on Colab we only have access to 1 GPU. But I do have this in the large, like a link to the documentation to check that out in the larger, intro and starter notebook for YOLO-NAS, which I'll share with Lexi. And here we're just setting up our data loaders. So super gradients, again, is fully compatible with PyTorch, data sets, and data loaders. So you can use your data loaders as is. For object detection, there's several well-known kind of formats for detections: Coco, Pascal, YOLO Darknet, YOLO v5, so on and so forth. We can handle all of those for you. And we also provide a ready-to-use data loader for those type of data sets. So our data set we've got in YOLO format. So that's why I'm using this particular function here. So we go ahead and we load up our data. And what's happening here is for the training data, Super Gradients is performing some image augmentations for you automatically. And so you can take a look at some of the augmentations that are being performed. And see what the augmented data set looks like. And the reason we want to do augmentation is because we want to make the task as challenging as possible, right? We want our task to be able to generalize well, and image augmentation is a way to do that. A big thing with YOLO type of architectures is using mosaic augmentation, and so that's kind of what you're seeing here: mosaic augmentation plus some other stuff happening. So we've got the augmentation set up, and now it's time to just instantiate the model. So all we have to do to instantiate the model is pass the name of the model. In this case, we're using the small model, and we're also passing the number of classes. So this is pretty much all we need to pass in, as well as the pre-trained weights. So the super gradients license for YOLO-NAS, it's a non-standard license, so you can use the architecture as is, just right out the box, without the pre-trained weights, just as you wish, like that. That's no problem. If you do plan on using the uh, model with the pre-trained weights, there's some restrictions to that, and so all of that's here in this license. But the architecture, everything is there for you to use. You can feel free to use the pre-trained weights for any non-commercial use case, essentially. Next is define the training parameters. So you need to define the training parameters for your run. So I've linked here for the full details about training parameters. You can check that out. But there are a few mandatory arguments that you need to define for training parameters. The max number of epochs, the loss function you want to use, the optimizer, training metrics list, the validation metrics list, the metrics to watch. It's all written right here. So Super Gradients also offers integrations with experiment monitoring tools. I didn't cover it here, but in the full larger intro notebook, you'll have details on that. But we integrate with TensorBoard, of course, weights and biases, ClearML, and also DagSub. So if your favorite monitoring tool is not supported by Super Gradients, we have instructions for how to get that set up, and it's not very difficult. So that's what we do. So now we've covered a lot of ground up to now. We've instantiated the trainer, we defined our data set parameters and data loaders, we've instantiated the model, and we set up the training parameters. And now it's time to train the model. All I got to do to train the model is pass the trainer object, the trainer.train, the train method of the trainer object, the model, the training parameters, where the training data is, where the validation data is, and just let it rip. And I need to, I didn't run it beforehand here, but we're not gonna make the same mistake as last time, Lexi. I ran this already before. So I've got the results here while this
Yeah.
trains, just
See,
to show you. Okay, so I didn't run any of this. My bad, Alexi. Uh, we're reliving the mistake that we made before, but I have the results here, so I'll show you that in a second. So
we
let's go
can
ahead.
trust you that it works.
Yeah, yeah.
Or if
So
it doesn't, then we will find you.
yeah, find me, hunt me down. But yeah, I just want to just show you what it looks like to train real quick. Um, while this is training, you'll see some outputs in a second, but I'll continue on with this notebook. All you have to do to get the best trained model is run this cell. So Super Gradients does a few different things for you. It does checkpoint averaging. So you can average the weights across various checkpoints and use that model. Or you could just get the last checkpoint if you wanted to resume training from that last checkpoint, or you can get the best train checkpoint. So it allows you a few different options for that. Then also you can evaluate the best trained model on the test set, just trainer.test, pass in the model, pass in the test loader, and then the train metrics list. And this is the same train metrics list that you defined in the training parameters. And you can see the results here. So these results are actually from training on 100 epochs on the data set that we had. I've done that previously for you already. And for each training epoch, you'll get a printout of how it's doing. So you can see the progress, monitor the progress as it um, performs, its training. And here, I just grabbed a couple of pictures of dice from the internet and passed it to the model here. So we take the best model, use a .predict function, and we're set up here um, like so. And you can see it's not doing too bad. There's a few missed detections. Remember that the number 5 was underrepresented, but it's picking it up here quite nicely. And overall, not too bad, considering the quality of the data set that we trained on and the number of images. Remember, we only have 300 something images. And here as well. So you can take a look at those detections as well. Super Gradients also offers post-training quantization and quantization aware training. I'm working on a notebook for that to show you how to make all that happen. So that'll be out soon, but you can learn more about that in the docs here. And that's pretty much it. You could see here how training progresses, and you get a summary of each training epoch. So you can monitor that as well. You can enable silent mode by simply changing verbose to be false. Um, that's it for super gradients. So I've linked here to a bunch of resources. Check it out. I think the best resource to get more in depth is this particular notebook here, which will walk you through much more in depth than we're able to cover here today. And that is it for YOLO-NAS and super gradients, Alexi.
Thanks a lot. Great presentation as always. I'm wondering, so how many people are actually working on this?
So our super gradients team at DESI is a small team. I believe it's only 4 or 5 people. Um, but the effort to bring super gradients to life was a lot more people. I've actually written a post on the newsletter about that. It was a good 10, 12 people that had to kind of work on this and bring it to life. Um, but yeah, super gradients is welcoming contributors. So please check out our contribution guidelines, and if you want to help work on the library, we welcome that.
So if somebody wants to contribute, they go to your GitHub repo and then they find the contribution guide. Do you have any good first issues?
Do you have any what?
First, good first issues for
Oh,
somebody
good,
to get started.
good first issues. We do have the good first issues tag. So if we do come up with a good first issue, we'll definitely tag it with that. Nothing right off the bat as of now. Super gradients just is uh, witnessing a overnight surge in popularity, which has been quite nice. So as we start filtering through those issues, we'll be sure to tag ones that are good first issues.
Do you have some sort of Discord or Slack channel or some Discourse, right? Have a
Yeah, it's
community
so we're actually on Discord now. It's the Deep Learning
Discord.
Daily community. Yeah. So
Mm-hmm.
so the Deep Learning Daily community, I've got a link to it in this notebook, and
Mm-hmm.
that's where you can find
I guess if somebody wants to contribute, then it could be a good place to ask for support, right?
yeah, definitely ask for support. Let us know your issues. It's just meant to be, in general, a place for deep learning practitioners to come together and just talk about deep learning. So if
Mm-hmm.
you're interested in deep learning, want to learn more, want to share your knowledge, want to share your resources, that's the place to do it.
And two, you showed us what are the plans, what's next on the roadmap.
Yeah. So next on the roadmap is just like getting through the issues and figuring out what it is that people want from YOLO-NAS. So uh, you know, we're still working on the roadmap, but I do envision us getting some support for object tracking and maybe making our segmentation models easier to use in the same way that YOLO-NAS is easy to use. Um, but whatever the community wants, I will advocate on their behalf to the engineers to get their requests onto the roadmap.
That's your job, right?
It is my job, yes.
Do you have any advice to anyone who's watching this?
uh, just don't be afraid to try it out, man. Just get in there and check it out. I think a lot of people in in deep learning make the mistake of just starting from like all the math first and then trying to work their way up. If you do that, you're going to be, unmotivated to continue. I'm a big fan of starting from the top and working your way down. And this is coming from somebody who has graduate degrees in math and statistics. Like, I don't recommend starting from the bottom. I recommend starting from the top, from the application level, just seeing the magic in action, and then going deeper as you need to.
Because you never know what exactly you need, right?
Exactly. Yeah.
Doesn't always make sense to study everything up front
Yeah.
because at the end maybe like yeah, don't need this 2 hours, two years of calculus.
Yeah.
Well, maybe you do,
Exactly.
who knows? But anyways,
Yeah.
thanks for the demo. It's nice to have you here as always, and I'm looking forward to seeing more demos from you.
Thank you very much, Alexi. Take care.